opening ArcMap. So before that, maybe let we see what we are doing or what we are going to exercise in ArcMap. So welcome everybody. It's just delineations of groundwater potential zone using GIS in remote sensing. So we will see how we use ArcMap, ArcGIS to delineate the groundwater potential of your catchment, your study area, and to say there is an excellent groundwater potential or good groundwater potential, very good, very poor groundwater potential zone. So at the end of this exercise, maybe we'll have a groundwater potential zones for the study area. Then what we will do is first it's better to see the data requirement. If you remember last time during the class we discussed that there are different factors which might affect the occurrence of groundwater. Yeah, there are maybe 5, 6, 7, 8, or maybe there are 10 or maybe more than 10 factors which might affect the groundwater potential of a certain area. And the software requirement just to process and to have the groundwater potential zone, you need to have ArcMap ArcGIS with a spatial analysis tool in ArcToolbox, because most of the things that you will use to reclassify and also similarly to overlay and to do the groundwater potential zones are located inside the spatial analysis tool. And those are might be the factors that we will consider in this exercise. Rainfall in one way or another might affect the occurrence of groundwater. Drainage density also will affect the occurrence of groundwater. Land-to-land cover change, again, slope, the higher the slope, the higher will be the runoff, the lower will be the occurrence of groundwater. And similarly, geology, because different geologic material will have different characteristics in order to hold water beneath your aquifer systems. And again, there are so many factors including clay content, for example, clay mineral content, alignment density, and alignment by itself. So the factors that you consider for your groundwater potential zone analysis will depend on your experience on the site, no? Yeah, it means the better you know the site, the better you decide which factor out of this you are going to use, no? So in different research, maybe when you read articles, you can see some articles they used 5 factors, the other 6, the other 7, and some of them maybe 4. Some of them they use rainfall, drainage density, land cover, but in other research you can get, rainfall may not be important, or slope might not be important. So in order to decide which data or maybe which factors to use, you have to know your study area very well, no? You have to understand what is happening on your study area or in the area that you want to have the groundwater potential zone. In the folder, I already provided you the factors that we are going to use. In the morning, I gave you those raster files. So when you see them, there is geology, and there is also alignment density, and similarly land cover, and again rainfall and slope. So for this specific example, we will use these 5 factors which we might believe that they will affect the groundwater potential of this area. So we will process them in ArcMap, and finally we will have the groundwater potential zone. So please open your ArcMap. Open your ArcMap. Yeah, so please add all those thematic layers into your ArcMap. Add all of them. Add all of them. Then when you add, please add slope, please add land cover, rainfall. There is a representation of land cover changes. Leave it. Alignment density and geology. Around 5 factors. Around 5 factors. When you examine those thematic layers, when you examine them, you know, this study area is located in Kombolcha. This is just Porkona River catchment. In each one of my MSc student, he was, I think he was defended last time. So what he did was he already prepared those thematic layers. So having thematic layer and processing is other thing, but preparing all the other thematic layers into the required format is the other things that you have to do before coming into this procedure. No? Then when you examine those files, for instance the slope, that means you can see that this is the slope, that is the slope that you can see. Maybe you can change the color for better visualization, and you can see that the slope is from 0 to 67. It's just from 0 to 67. So from the groundwater perspective, you can imagine that the lower areas, that means with those values, the one you can see here, they will have a higher groundwater potential because they do have low slope, but those areas with this, they will have, you know, a lower groundwater potential. When you come to, for instance, land cover change, you can have bare soil, shrubland, grassland, moderate forest, and water body. So maybe you can assume that water body has high groundwater potential rate in comparison to the other land covers. And rainfall, the higher the rainfall, the higher will be the possibility of having a groundwater potential, and the lower the groundwater potential. The alignment density also, the higher the value, the higher the probability of groundwater occurrence, and the lower the value, the lower the probability of groundwater potential zones. The geology, in order to understand and in order to interpret the geology in relation to the groundwater, you have to understand what is the geologic material within each and every group. So in that case, you can easily give the required amount of rate for each and every geologic groups. So the next thing that we will do after having those thematic map is to reclassify. By meaning reclassify, for example, when you come to the land cover thematic map, when you right click on it and open attribute table, you can see that it is already reclassified. It's already reclassified because you can have values like 1, 2, 3, 4, and 5 with different land use values. And again, the geology is also already reclassified because you can see the attribute table, and it is already reclassified into 5 groups. Yeah, the first group is with this value, the second group, the third, the fourth, and the fifth group. So geology and land cover change, they already reclassified. But when you examine slope, it's not reclassified because it showed only the pixel values from 0 to 67, and similarly rainfall, again it needs to be reclassified, and the alignment density also has to be reclassified, or it has to have a reclassification, no? So let me classify, for instance, a slope. So to do that, please right click on it, and go to properties, symbology, classified. Then here you can see that the classification is natural breaks, it's okay, and the classes are 5. So when you reclassify those thematic layers, it will depend on how many zones of groundwater potential do you expect at the end. How many do you need? Maybe 4, that means maybe very good, poor, very poor, or maybe 5 including moderate. So the reclassification will be depend on how many groundwater potential zones do you need at the end. Yeah. So for this specific example, let we assume at the end we will have 5 or 4 groundwater potential zones. One zones with very good, the other zones with good, the other with moderate, the other with poor and very poor, or maybe there is no moderate but 4 groundwater potential zones. So the reclassification here will depend on the output that you need, 5, 4, or maybe more than that. So let me assume 5 is okay. Yeah. So please click on apply, and okay. So now we will have 5 group of slope. Yes, 5 group of slope. That means from 0 to 7 degree to 15 degree to 23, and like that. So we will do the same for rainfall and alignment density. We will do the same for rainfall and alignment density. So again, go to rainfall, right click on it, properties, again classified, again 5 group, that's okay, apply, and okay. So for the rainfall also we'll have those 5 groups. That means the rainfall in millimeter from 978 to 993, and 1045 to 1073. So we will have 5 groups of rainfall, and do the same for alignment density. So right click on alignment density, go to properties, again classified, and 5 groups, that's okay. So apply, then okay. Now we all have the classified thematic map for the 5 factors: the slopes, rainfall, land cover, alignment density, and geology. That is the first step that you have to do just to start your work. But for example, try to open the attribute table of this slope. It is just inactive. Yes? Yeah? It's just inactive. And plus, try to also land cover change, it's active. And similarly, rainfall is inactive, alignment density is inactive, but the geology is active. It means we need to reclassify again those three thematic layers. That means the slope, the rainfall, and the alignment density has to be reclassified in real. To reclassify, please go to Spatial Analysis tool in your ARC toolbox. Please go here in the ARC toolbox, expand it, and go down until you see the tool Reclass. Reclass. I will show you why we have to reclassify again, because our aim is to do this overlay analysis. So in overlay analysis, unless you reclassify it in real, it will not show up. That's why we need to have a reclassification. Expand this reclassification, then please go to reclassify. Here, when you click on this down arrow, you do have those 5 thematic layers. The 5 thematic layers. So let you reclassify the slope. Reclassify slope. So you can see here that the old values are those slope in degree, but the new values that we will see later here are the reclassified numbers from 1 to 5. So please try to understand that 5 means higher values, no? And 1 is the lower value, because it will help us later to decide when we are trying to give scale in overlay analysis. So if it's okay, please try to write the file name reclassified slope. Reclassified slope, and be sure where you want to save it. So if you want to save to a separate folder, so you can click here, then click on OK. I think it's just working. Yeah, now we have the reclassified slope. We have the original slope, and now we have the reclassified slope value. Do the same again for rainfall. So open reclassify, and please open rainfall thematic layer. Again, you can see that the new values are from 1 to 5, and 5 means higher rainfall values, and 1 means lower rainfall value. Again, please change the file name into reclassify rainfall. In that case, I can write RA. Then click on OK. Now you can see the status bar, and the reclassified rainfall is already generated. Do the same for alignment density. We have to reclassify again this alignment density. So open reclassify and go to alignment density, and you can be sure that 5 means the higher drainage density value. So please change the file name into reclassify DD, which is drainage density. Then you can click on OK. Then we do have the reclassified drainage density here. So we have the reclassified drainage density, the reclassified rainfall, the reclassified slope, and the other land cover change already reclassified before, and similarly also the geology is already reclassified. So maybe it is good to bring the land cover change up because we need it, and similarly good to bring the geology thematic map up, maybe here. So it means we had our 5 thematic layers: reclassified drainage density, reclassified rainfall, reclassified slope, reclassified land cover, and reclassified geology. So we don't need the other thematic maps for now. So it is good sometimes to manage your data on ArcMap. Sometimes you will use a different thematic map rather than using the classified thematic layer. So the data management in ArcMap is very important. It means simply let we group these 5 thematic layers together. So please right click on layers, and click on new group layer. Then please change the file name into maybe final map, or maybe for overlay, because we are going to do overlay analysis. And put all of these 5 thematic layers here. In that case we will have those final thematic layer for our overlay analysis. It means simply bring, for instance, drainage density up, so leave it here, and similarly reclassify rainfall here, and similarly reclassify the slope. Do the same for the other 2 up to geology. So it means we form one group with for overlay, which includes those 5 thematic layers. So we had 5 reclassified thematic layer, and those are just the inputs that we are going to use them during overlay analysis. So before we use overlay analysis, there are some things that you have to understand in order to use this overlay analysis. So what is the concept, or you have to understand the concept of overlay analysis. So when you do overlay analysis, there are 2 important terms, we will see later during our exercise. The first thing is influence, and the other thing is scale value. The influence is the overall importance of a layer. It means simply, in this specific example we have 5 layers. So which layer is the most influential to produce a groundwater potential? Is it rainfall? Is it lineament density? Or maybe is it some other factor? That is what is meant by influence. And the other important term is scale value. By meaning scale value, in each and every thematic layer we have different groups. For example, when we take a slope, we had 5 groups, from 0 to something, 0 to something, and something like that. So how are you going to give them scale? That means which factor, or maybe which group is very important to produce the groundwater potential zone. So we will going to use a rating value from 1 to 5. So 1 means less important and 5 means most important. So we will consider influence and we will consider also scale values. So bear in mind those two terms and let me do overlay analysis. And the main question still is, how are you going to determine the influence percentage or the influence value? Percentage is 100, but are you going to give 50% for rainfall and less percent for the other? Or are you going to give maybe 10% for geology and maybe 5% for land cover? You have to decide, no? To decide, the first very important thing is knowledge of or experience of the study area. But there are also some tools which might help to make you decide better. Some small softwares or some small Excel. And most of the time, the weightage, in other terms, is called weightage, or the influence can be maybe supported by using AHP, which is analytic hierarchy process. So in the folder that I provided you, I already gave you analytic hierarchy process calculation Excel sheet. Yeah, you have it, AHP calculation Excel sheet. This is just the Excel sheet, but they do have also AHP software. This AHP calculation Excel sheet will be used only if your factors are up to 10. It will work only for factor up to 10, but if you consider your factor more than that, then you have to look for the original pairwise or AHP software. So to start to use AHP, first let we see what is this overlay, what is overlay. So the overlay analysis can be easily located the same inside the spatial analysis tool. So inside the spatial analysis tool, you can easily locate overlay here, yeah. Please expand this overlay and what we need is a weighted overlay. We have to do a weighted overlay. Open weighted overlay, and this is just the weighted overlay table that we are going to determine the influence, that is the weight, and the scale, which is the value within each thematic layer. You can add the thematic layer by clicking on this plus sign. Let we add all of them because we had 5 thematic layers. Please click on here and please call upon the first thematic layer, which is reclassified drainage density, and click on OK. Now you have the reclassified drainage density values. You are going to give scale, and similarly add the others. For instance, rainfall, okay, and similarly a slope, then okay, again land cover, and the last one is geology. So we already added the 5 thematic layers that we believed they will affect groundwater potential zone highly. Reclassified DD, rainfall, slope, land cover, and geology. So the most important part is how are you going to give the influence, that is the percentage influence. And how are you going to give the scale? The scale might not be that much difficult because you know the relationship between different thematic layers in relation to the occurrence of groundwater. So the idea of using this AHP analytic hierarchy process will come in order to determine the percentage influence. That means for reclassified drainage density, how many percent are you going to give it? That means the weight, the influence. By what percent drainage density will influence the occurrence of groundwater? And by what percent rainfall, and similarly the other thematic layers. But the summation of all the influence should be 100%. So in order to decide on that value, that's why rather than giving, for example, simply 30, 20 and also 10, 15, 5, etc., it is good to use AHP analytic hierarchy process, which might help you to have a better decision. So please open the AHP calculation Excel sheet that I provided you. That means this one, and this is just AHP analytic hierarchy process, the Excel version, and you have the option to change values in light green. That means here, 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 and similarly here. And those are just the criteria, the factors that we are going to consider. That means the 5 factors. So N is the number of criteria. How many are they? 5, yeah? Rainfall, drainage density, yeah? There are 5, so you have to write 5 here. So you can see it will automatically show you the bar chart. And our objective is determining groundwater potential zone. Potential zone using GIS and remote sensing. And maybe if you want to have to write outer and date, maybe now it's not that much important. And you have to write those criteria here. We have 5 criteria, that means 5 factors. The first criteria is rainfall, so you have to write there. Maybe the second criteria is geology, and the other one maybe you can write alignment, density, and similarly you can write slope, and the last one might be what? Rainfall, geology, alignment, density, slope. What is the other factor? Land use, land cover change. Those are the thematic layers or the factors that we are going to consider in this example. So when you do that, it will automatically show you the matrix. This is just the matrix. So in this matrix you can see that those thematic layers in the X and similarly those thematic layer in the Y direction. And you can see also in the bar chart that is rainfall, geology, up to land cover. But what we are interested is to have the weights. Those weights are the percentage influence that we are going to use in ArcMap. That means in this overlay analysis, we need those percentage influence. So those percentage influence are those weights in AHP that we are going to produce. And what this AHP use is, it will compare each and every factors in pairwise way. That means it will compare rainfall with the other 4, land cover with the other 4, and similarly the other factors with the other 4. Again, because we wrote here the thematic layers, automatically they are also displayed here in the sheet. For instance, check the first sheet. So in the sheet they are already wrote, no? Yeah? And it's also already makes them to be displayed and compared in a pairwise manner. That means A is rainfall, geology, alignment, density, slope. So rainfall will be compared with the other 4 thematic layer, and similarly geology with the other, and alignment density with the other 2, and slope with land cover change. Then the next thing that we are going to do is we have to determine which one is more important. Is rainfall important than geology, or geology is important than rainfall? Or is rainfall important than land cover, or land cover is very important than rainfall? So you have to give your decision here. You have to give your decision here. And you have to give a scale values from 1 to 9. So when you give a scale value from 1 to 9, what does it mean, for instance, when you give 1? And what does it mean when you give 5? And what does it mean when you give 9? So those scale value means like this. It means when you give 9, it means one factor is extremely important over the other. Take into consideration. And when you give 7, it means one factor is very strongly important over the other. And when you give 3, it's moderately important. But if you give 1, it means equally important. It means rainfall is equally important to other factors, just for a groundwater potential zonation. Do you understand that? Yeah. And in this Excel also you can have the same. That means 1 means equal importance, 3 is moderate, 5 is strong, and 9 is extremely important. So we will give 1, 2, 3, 5, 7, 9. Okay? Then let me compare rainfall, geology, which is very important. Rainfall. So maybe you can have here rainfall, so it means A, because rainfall is in A and in B, those things. So rainfall is geology, so A is important. So how much are you going to give in scale from 1 to 9? Let me give it that rainfall is, I think geology is also very important. Yeah, but rainfall is much important, because if there is no rainfall water, there is no recharge to the system. So there is no, maybe you can say that the groundwater will decline, etc. So rainfall is important than geology, but how it is important, you have to give a scale. Is it equally, or maybe it's strong in importance, very strongly, or extremely important? So in that case, maybe let us select strongly important. 5. That means rainfall is strongly important than geology. Again, compare rainfall with alignment density. Again, I can say rainfall and strongly important. And rainfall with the slope. Again, rainfall and very strongly important. 7. I gave it 7, very strongly important, because 7 is very strong importance. And compare again rainfall with land cover change. Again, I can say rainfall and then maybe strongly important. Come again here. Look, we compare rainfall with those 4. So the next is geology, has to be compared with the other, no? So how are you going to give weight? Is it geology or alignment density which will affect highly the occurrence of groundwater. You can say quite important, because geology is very important, and again sometimes lineament density is also very important. Yeah. So let me give maybe geology, and the scale might be 3. Yeah. 3. And geology and the slope. Geology is very important, so I can give the value 5. And again geology and land cover change, I can say that both of them are maybe equally important, so in that case I can give 1, because equal importance means 1. And go down again, compare lineament density with the slope. I can prefer lineament density over slope, and I can give 5, which is strongly important. Alignment density with land cover change, I can say both of them are equally important, so I can give 1. And again do the slope and land cover change, so what I prefer is land cover change is more important than a slope for occurrence of groundwater, so I can give here maybe B. That means this is very important, and I can give 5 maybe. So like I said, this is just a personal judgment, but this personal judgment should have to be supported with experience on the study area. Yeah. So, and how are you going to be sure that this is concise, or how are you going to be sure this is acceptable? So to be acceptable, it will depend on some guidelines. That means you have to have a consistency ratio. For example, when you go back to the Excel, you can see that there is a consistency ratio CR here. It says, for example, 8%. The consistency ratio is 8% for this specific calculation. So how are you going to accept this 8% is okay or not? You have to follow certain guidelines. So if CR, consistency ratio, is less than 0.05 for 3x3 matrix, and 0.09 for 4x4 matrix, and 0.1 for large matrices, then the pairwise comparison is said to be consistent. So in our case, how many matrices do you have? It is just 4x4, yes? We do have 4x4 matrix, no? I mean 5x5, yeah? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, yeah? We have 5x3 matrix. So if it is greater than, larger matrix greater than 4x4, then 0.1 is okay. So in our case we had 0.08, 0.08, yeah, so we have 0.08, so we are safe, no? We are safe. But still, what we need is to have the percentage influence values, those values, yeah? We are working on AHP just to have those values. Then what are the weights? What are the weights that this AHP calculated? Go back to the summary and you have the weight here. It means rainfall has 54.3% influence, and geology 17.5% influence, lineament density 11, slope 3.7, and land cover change will have 13.3% influence. Yeah. So what are you going to do is just have these values and put it inside your overlay analysis. Rainfall is 54.3, so go to the rainfall layer, that means this one right here, 54.3. and again you have geology, which is 17.5%, so please find the layer geology and give it 17.5%. And do the same for other thematic layer. For instance, lineament density is 11.2, so go to lineament density drainage density, I think, yeah, drainage density is just 11.2. So here you can write 11.2, and a slope is 3.7. so go to the slope layer, that is the slope, so this is just 3.7, and the less thematic layer will have 13.3% influence, that is the land use, land cover change will have 13.3% influence. That means this one, which is 13.3. Now you can see here a red point here because the summation is still not 100%. So when it will be 100%, so that red will be gone. No? So I can write here 13.3. 13.3. I don't know, it's not writing decimal. So 1154 17 1154 17. So Kahoot is not taking like those numbers for like after those maybe, so we can add them to the other group, so no problem. But still it is just in red because the summation should be 100, no? So you can add like 11 plus 54 is 65. 65 3 is 68. 68 70 81 81 98. So maybe I can make this one 15. In that case it's just okay, no? So the weighted overlay is okay. So that's how you give the weightage or the percentage influence. And the other very important thing is also the scale. The scale. Those field values are the reclassified field values that you can see here. For example, in reclassified drainage density, you can see that reclassified drainage density, those values means this one, yes, 1 2 3 4 5 1 2 3 4 5. So you have to give a scale value here. That means 1 means less important, 5 means most important. So when you compare the drainage density, the higher the drainage density, the higher the probability of groundwater occurrence. So it's okay, 5 5 and 1 1. And go back to rainfall again, it is okay, but first you have to give here, when you go down, you do have evaluation scale, no? So this evaluation scale should be 1 to 5 because we are working on 5 reclassified scales. So please try to put this one 1 to 5 by 1. This one is 1 to 5 by 1. So the rainfall is going to be okay. This is just no data value because we don't have more than 5 scale. So let we give a different scale values. For instance, the drainage density, it says 1 2 2 3 3. Let we give from 1 to 5. Let we say this is 5, this is 5, and this is 4. So this is 3, this is 2, and this is 1, because the higher the drainage density and the higher the occurrence of groundwater. And similarly for rainfall also give the last one 5 and the next one, which is 4, and this one 3. Go to the slope. Now slope has a reverse influence, yeah, the higher the slope and the lower. So I can give here 1, yeah, because this 5 means high slope value, because you can see your slope thematic layer here. So the last 5 indicate this range from 34.28 degree to 67.25, so which has less importance. Yes, so please in the slope write here 1, so let me write here, it's not working, I don't know why. The first one 5 and this one 4, this one 3 and this one 2 and this one 1, which has a reverse relationship, 1 5 2 4 5 1. Yes, and go down to land use land cover. So for a land use land cover change, you have to see what does the reclassified land use land cover mean. So when you come to the land use land cover, you can see bare soil, shrubland, grassland, moderate or forest, and water body. So we are talking about having groundwater potential, so water body is most important, yeah, because they will give water to your aquifer. And similarly, forests are also most important because they will give water to have time to infiltrate, and grassland and shrubland maybe they will have similar influence, and bare soil which will have less important because all the water which come from rainfall maybe will be converted into runoff, yeah, because there is no plantation on that area. So giving the influence means 1 for bare soil, which is less important, and these two maybe we can give number 2, and this one is maybe 3 or 4, and the last one is 5, which is very important. But you have to be sure, because here we do have only values, that's number. You have to be sure what means 1. Is 1 mean bare soil, or is 2 mean shrubland? So in that case you have right click and check on the attribute table. So 1 means bare soil, yeah, so it means they are written like this, no, 1 bare soil, 2 shrubland, 3 blah blah. So they wrote on the order. So when you give a scale, I can give for a bare soil 1, that's okay, and for shrubland and grassland 2, it's okay, because you can assume that they do have similar importance. And moderate forest, maybe you can give it a 4, and you can give water body, which is very important in this case, you can give it 5. And the last part is geology. You know, in this geology part you have to know what does it mean, those codes. So maybe let me remind you what does it mean, those codes. So you can see that when you try to see the geology, here, you do have different names, no? For instance, it says N12, KR2. This means Magdala geology. It means it consists of rhyolite, agglomerate, and basalts. So you have to know those information, and it is with joints mostly of covered by agriculture. That means this code. And the second one, which is with a code P2AB, it is just a geological Ashange formation. So you have to understand what is the relations of this Ashange formation with the hydraulic conductivity, because what you are looking for is hydraulic conductivity, no? The higher the hydraulic conductivity, it means the higher the water to infiltrate and join your aquifer. So this P2AB is geologic Ashange formation, in which it is just deeply weathered rock with good hydraulic conductivity. So bear in mind that it is just with good hydraulic conductivity. And the third one is basalt. That means it's just basalt, but with fine-grained material. That means clay. So you have to be considered, if there is clay, how will be the relations of that rock material with groundwater. And this one is quaternary alluvial and lacustrine sediments. which are also you have to consider, and we might not consider this water body. I don't know, this water body is also coming to mind. So after investigating and knowing the relations of the geologic formation into groundwater potential zone, you can give the scale. In my case, I was trying to give this P2AB. You can check that what does these codes or these numbers in relation to the name. So 1 means this N12 KR2, so you can give for N12 KR2 4. So I can give here 4, and 2 means P2AB, so I can give for this P2AB 5, which has a high hydraulic conductivity, so which favors the occurrence of groundwater. And 3 means this PNDB. In that case, PNDB is basalt, in which I can give it 3. Even if it is basalt, it has columnar joints that features faults, so there will be the probability of water to move here and there through those passageways, which will be maybe a productive aquifer. So in that case, I can give the value 3, and the other 2 parts maybe I can give them 2 and 1. So by this we finish the scale value and we finish the percentage influence. Then when I click OK, or maybe when I click when I save my file, I will have a map which will give me the groundwater potential zone of that area. But bear in mind that we gave a scale value from 1 to 5. So when we gave 5, we were saying that it is just very important. Yes. When we gave 1, we are saying that it's just less important. So finally, the results that we will get maybe will have a values in which they will use this formula. That means the groundwater potential index or groundwater potential zone can be calculated using this arithmetic equation. In that case, this Wj is the weight for geothematic layer, and xi is the rank that we will give the scale. So this W is the percentage influence. This is the scale for each and every thematic layer that we assumed they will influence the groundwater potential for this specific example. So lastly, maybe we will have groundwater potential zone from 1 to 5 or from 1 to 4. In that case, by meaning 1 is just very poor, less important, and by meaning 4 is just very good, which is most important. In that case, we will have high groundwater potential zone. And if you have also more class like 5, it means we can assume that we do have also a moderate scale groundwater potential zone. So let me do that. So maybe let me save it weighted, or let me save it with the file name groundwater potential zones. That means groundwater potential. So I can click on OK. Now it's just working. You can see here on the status bar. So maybe after calculating, I will have my groundwater potential zone, which has a 5 group, So it means we can assume that 5 is very good, and 4 is good, and 3 is moderate, 2 is poor, and 1 is very poor. So by this, 5 means very good, no? So we can change it into very good, and 1 means very poor groundwater potential zone. It means when you consider them, with this color, with dark green, you can see that the dark green areas are only concentrated here. Yeah, it means those areas will have high groundwater potential, and the areas with 1, that means red, dark red, they are very small areas. You can see that somewhere here. Maybe you can change also the color for better visualization, but those rates are this point, some point, and this point, and the other points, they will have very poor groundwater potential. But most of the area, as you can see, they are just on the region of 4 and 3. Yeah, so 4 and 3 means you will have good and moderate groundwater potential on those areas. You can get a good and moderate groundwater potential. So the other thing is like how an area, like how much area you can say is having good groundwater potential, and how much area in your study area would have lesser or maybe poor groundwater potential. So it means you have to calculate the area of the pixel, yeah, the area of the pixel that you have. So to do that, maybe you can open the attribute table, open attribute table. Then in this attribute table, you can see that we have only the pixel count, no? We have only the pixel count, but you need to have the area. So please add another table here. That means go here inside table option, then add field, add field, add field, and write the name of this field, area in square kilometer, area in square kilometer. And please try to select float, because we will expect also decimal number. So when you expect decimal number, in that case it should be either float or double. That is, maybe let me select now float, then you can click on OK. So we do have the area in square kilometer colon that we are going to calculate. So imagine we have pixel count, the pixel count, that means the pixels. So we are going to calculate the area. So before calculating the area, please check what is the size of the pixel, or what is the cell size. So maybe you can right click on groundwater potentials and go to properties, then go to source. So here you can see that the cell size is 180 by 180. Of course meter, of course meter. Maybe there are some projection etc, that's why it's just 180 by 180. So it means one cell has 180 by 180 meter. So 180 by 180 is the area of a single cell, no? So when you count, or when the system counts, for instance, in the very most important groundwater potential zone, there are 1491 cell, number of cells, no? So one area is 180 by 180 times this count, and maybe the conversion factor into kilometer square, because this is just in meter. Yeah, so to do that, please right click here on the top of this area in square meter, in square kilometer, sorry, right click and go to field calculator, go to field calculator and click yes. So what are we going to do is count, that means the cell, times the area of each pixel, which is 180 by 180, 180 by 180, divided by a million, no? Because we are going to convert it into square kilometer. This is just in metric unit. So it means 1,100,000. Then you can click on OK. Now you will have the area. It means within your study area you will have 48.3 square kilometer, which is very good groundwater potential zone, and you have this amount which has very poor groundwater potential zone. and similarly moderate and also poor groundwater potential, something like this. So this is how you determine the groundwater potential zone of a given area, or your research, or maybe your study. But like I said, these GIS and remote sensing techniques not apply for only determining this groundwater potential zone, but also if you want to analyze drought index of a certain area, if you want to analyze also the flooding, if there is a flooding problem for a certain area. So the idea is the same. You can overlay different thematic maps, but you have to consider their influence, because one factor may have favorable influence over groundwater, but not over drought and maybe flooding. But you will do the same, and you can produce similar result for the groundwater potential assessment and other processes if you are interested. So I believe you capture some information. I know I am just a little bit faster because just the timing, and I will give you also the materials or the audio that I am just recording. Then in that case maybe you can practice in your room also. That is it.